Hello, good morning. Thank you for the opportunity to present. I'm honored to share with you some of my experiences and learnings as an early pioneer in the space of chaos engineering and building reliable systems. Today, I want to talk to you about how many nines are enough. A lot of times we strive for 100% availability, high availability. And the truth is that's very expensive to accomplish. It requires a lot of additional work to achieve. And so what we truly want is the right number of nines, the right availability for our team, our service, or our company. Now, I often have slides like this in my talks, and it's a bit bittersweet because there's always a major outage that we can talk about. Here we are, early 2021, and we came back from the holiday break in America to a large Slack outage. And as a CEO of a company, it was unfortunate because my team, who was ready to come back and get ready to work, basically couldn't do anything for the morning. They had to re-explore how to communicate. Things were dropping to email or different IMs, and there was just confusion. This is what our customers experience when our software fails. It can be that they're unable to run their software. It can be that they are unable to purchase things from us. It can be a huge revenue loss. It could just be a loss of customer trust, that when they go and load our website or our service and it fails, they assume that we aren't doing the best work that we can. So why is this the case? Why are we seeing these outages not only continue to occur, but to occur at a more frequent pace? Well, let me step back. My background is in engineering, and growing up, I worked for Amazon and Netflix. As when I was at Amazon, I was part of the retail website availability team. It was our job to make sure the website didn't go down. And if it went down, we were losing money and customers were unhappy. Same story at Netflix. At both of those companies, what I saw was very complex systems that had developed. As we built microservice architectures and distributed systems, this is a snapshot of Netflix back in 2012 and just the Amazon retail website back in 2009. These are arguably simplified views of these systems. And so this complexity that has come from our design decisions, which are good design decisions, the ability to isolate things, the ability to deploy things, the ability to move quickly, are critical to our innovation and being able to bring our products to market. But the truth is that the testing we're doing hasn't kept up with the complexity of our systems. We're continuing to test just the code that we're writing, not the entire environments that we're operating in. And this is not sufficient. We're like an iceberg. We're thinking about what we're seeing above the water, when in reality, a large portion of our system and what could go wrong lives beneath the water. These are things like our dependencies, our internal identity service, our service discovery. It could be our external dependencies, our cloud provider, our identity provider, a partner, a government software that we interact with. All of our systems, all of our code is running on operating systems that are hundreds of thousands of lines of code with many different types of configuration. What about timeouts? What about thread pools? What about rerouting when things go wrong? What about security groups? If we haven't thought through and tested this configuration, we might be surprised when things go wrong. And beneath that, we have our infrastructure, our platforms. Oftentimes we treat these as solid bedrock that we can build upon, but they too may have issues. And if those things happen, we need to make sure that we can handle it. Now, you go back 10 years, this is what Chaos Monkey was built for. A host could be rebooted at any time, and you need to be prepared for that. Lastly, we have our people and processes. And as technologists, we often think and focus on our software, our build and deploy, and the choices we've made. But if our teams haven't had an opportunity to practice being on call, then we're going to get in trouble. And so we want the opportunity to give them that training. At the end of the day, we would like to have our cake and eat it too. We would like to be able to innovate, move quickly, and maintain a high rate of availability. And what we learned working at Amazon and Netflix is that if you want to maintain this high speed of velocity and innovation, you have to change your approach. And we found chaos engineering to be the effective means to allow us to test and validate our software while investing just the right amount of time, the minimum amount of time. When I'm home for the holidays or I'm with my family, I often explain what we do in the form of an analogy. And I think the vaccine analogy is very apt. In this day and age, when many of us are working from home and dealing with the coronavirus pandemic, we're all quite excited to have a vaccine that will allow us to return to a semblance of normal and behave in a more normal fashion. Well, the same thing applies to our distributed systems. Those types of failures, just like a virus, could happen. They could propagate, they could cause a cascading failure and bring our systems down. By administering a vaccine, by allowing our teams to test the failure, to test their response, we're training our teams as our body trains antibodies. We're teaching them how to respond to this type of failure so that when it occurs, it becomes a non-event. And so something that could have been a catastrophic outage can be turned into a benign issue with this proactive approach and a vaccination. I spoke a bit about safety. And again, one key concept here is who is going to be impacted when we run this experiment. Our goal is not to run at 100% in production for the first exercise. That would be reckless. Instead, we want to begin in development or staging. Now, we need to go to production in the end. Production has a class of failures, a traffic load and diversity that staging does not and never will have, and configuration and different network paths that absolutely must be exercised. So how do we do that safely? Well, we start with the smallest experiment that will teach us something. If we can run this on a single host, a single user, a single device, and uncover what would have been a major outage, that's efficient engineering. And if that works the way we expect, then we've built trust and confidence that our system will respond correctly. And that allows us to increase that blast radius. So we'll go from a single host to 10 hosts, to 100 hosts, to 1,000 hosts. And at each step, we are validating that the system can withstand that level of stress and issue, and that we're comfortable moving forward. So we've had an opportunity to talk a bit about the basics of chaos engineering, the basics of operations. So a 2-9 system. So we have 2 nines of availability for a reminder, that's about 3.5 days of outage. So this is a pretty low bar. We're probably only in this world in development or very early days of our service or company. In this case, things are breaking and they're breaking often. And our customers have an expectation or a perception of a beta or a not production ready software. In this world, it's often one person's problem. One person is dealing with these issues, these outages, the code changes, and it really rests on their shoulder. And we're not really investing in reliability yet as a company. It's not a top priority, and it becomes one as the pain begins to mount. So in this world, what do we do to get to a better place? How do we get to a 3-9s world? Well, we need monitoring and alerting. If we don't know what's happening in our software, then we're not going to be able to respond to it. We need to know what's happening in our systems. The second step is we need a good and repeatable build and deploy process. If people are writing code, packaging up, and shipping it to a server on their own, we're probably going to have a lot of issues and outages related to that. So getting in a good continuous delivery pipeline so that we can test these becomes paramount. We need an incident management program. We need some responsibility, some reporting, some understanding of the issues that are happening. Someone needs to take the role of the customer advocate and understand the pain that they're feeling. Someone needs to articulate for product that when our software isn't working correctly, our customers are unhappy and it's difficult for us to make money or to build their trust. And then if we're lacking redundancy, if we'd built, a single server, a single zone, this is the time to add more redundancy. 3 hosts per zone, or a host per zone, 3 hosts per region, so that if something goes wrong at the bare minimum, we have a backup. And this is a common pattern in reliability, identifying your single points of failure and where possible, adding a backup so that there's redundancy. So one important aspect here, I talked a little bit earlier about training our teams. And sadly, my experience in the last 10, 15 years of our industry has been that we're not very good at preparing people to go on call. In a lot of places, we hand our engineers pagers and we say, you're smart, you'll figure it out. There's a run book over there. We haven't looked at it in a year. Maybe go update that. I imagine a world where things operate differently, where when someone is about to be on call for the first time, we give them an opportunity to practice. We use a tool like Gremlin to simulate an outage that triggers our incident management process. They get paged, they get engaged, they log in, they look at the dashboard, they log into the host. Just knowing that those things work correctly could save us a precious 5 or 10 minutes during a major outage down the road. And there's good precedence that this is a good idea. Many of us have grown up participating in fire drills. I know in particular in Japan, earthquake drills are paramount. And knowing that an earthquake or a tsunami could occur, we must prepare for those things. Well, by drilling and practicing, people will know how to respond, and they can respond calmly and safely, as opposed to running around with their hair on fire. Another key aspect is to use chaos engineering to validate our alerting and monitoring. If we're getting paged all the time, our engineers are going to tune it out and start to ignore it, or they're going to get burnt out dealing with it. We want every alert to be actionable, something that a person can take. And if it can't, we want to automate it. When I first joined the API team at Netflix, we had 350 alerts on our service, many of which predated every team member. No one was willing to delete an alert because they thought it might be something important. But the truth is, they didn't know. It was the fear of the unknown that prevented them from cleaning up that noise. And so an exercise that we did was to go through and to force every alert to fire and to validate that it was a useful and actionable alert. And at the end of that, we had 45 alerts where previously we had had 350. It still sounds like a lot, but it was much less noise. And those captured important failure modes that we were aware about when it came to our system. All right, so this gets us to the 3 nines world. I think this is where your average software company is at today, even some very big names that you may have heard of. Things tend not to fail, but we're seeing failures now and then. These tend to come once a month, once every other month, and it might last for an hour, it might last for 20 minutes, but it adds up to being a substantial amount of time throughout the course of the year, about 8 to 9 hours. In this case, our customers aren't seeing it often, so they don't have the perception that our software is broken, but they're annoyed. And when it does occur, that is an invitation to send them into the arms of one of our competitors. If our website is down and they can't purchase what they want, now's the time that maybe they're going to try another website and check it out. We don't want to give them that opportunity. Obviously, we want to keep them happy and focused on our product and our service. This has often grown beyond a single person's life into a team that is focused on the reliability of the software. And that team has its pros and cons, as we'll discuss. But in this world, we're performing incident reviews. We're talking about the things that are happening. And this gives us the advantage of sharing the information about our system and our failures with our team members and our other service owners so that they could prepare for things before they occur. So this is a good spot. And since this is where a lot of folks are, what do we do to get to the 4 nines, the next threshold? Well, one is, as I discussed, reducing noise in our alerting and in our monitoring. We want to make sure that we're aware of what's happening that's important, and we're ignoring the things that aren't important or aren't actionable. Oftentimes, this is where we start to layer in canary deploys. We want to be able to deploy software to a limited set of customers to be able to see that it behaves correctly before we roll it out to everyone else. Do you remember the discussion of the blast radius? This is just the blast radius for deploys. It's the same concept. We want to test out that it works before we put the entire population at risk. In this world, we're sharing what we're learning. If one team has an outage, they're letting the company know so that other teams don't get caught unaware. And if it's something that is systemic or unique to your environment, it's an opportunity to highlight that for folks, to document it, to make sure other folks don't find those sharp edges unaware. And then we want to move to more redundancy. In this case, it might be moving from a single data center to multiple data centers. It might be moving from one cloud region to multiple cloud regions. But we know that data centers and zones and regions, cloud providers are in our own control fail. And we need to be able to have a plan to operate through those failures. So as I mentioned, testing the node failure, the pod failure, the zone failure become critical. Testing what happens if we lose network connectivity. If a network cable is cut between our data centers, are we still able to communicate? we're unable to talk to one part of our system, how does that handle consistency? These are important questions to ask and to be able to verify. All right, so now we're moving up into the 4.9s world. This is where we want to be. Things are failing, but not failing as often. We're probably seeing one failure, maybe 2 failures a year. And hopefully when these things are failing, our customers aren't noticing. Now, we may still have the one big outage, but there might be little outages where we're able to gracefully degrade, where a part of our system breaks, but the whole system doesn't need to break. And so that one piece can go away, so to speak, and our customers can continue to use the rest of our offering unabated. In this world, our teams are prepared, but they're being interrupted less often. This is where we're really moving to many teams are caring about reliability. It's not one person's problem. It's not one team's problem. It's the company's problem. And we need to be able to share that risk, share those learnings, and all do our part to protect that customer experience. And to do that, we're really sharing our best practices. We're sharing that context and the things that we've learned. We're sharing the experiments and the exercises that have prepared us and help us to be successful, so that our other teams and coworkers can benefit from that. And this is really what we aim for. This is really, to me, the critical outcome of chaos engineering and of focus on reliability. We want a culture of resilience. We want everyone to understand that building high quality resilient software is part of all of our responsibilities, that we all guard that customer experience. We all want to ensure that we're doing our best work and our customers see our best work. And to do that, we amortize the cost. What might be too much for one person or a lot of work for a single team might only be something that everyone in the company does weekly or monthly that is able to amortize and provide that benefit. So great, we make it to the 4.9s world. How do we get to the 5.9s? How can we get to that exciting world where nothing ever fails? Well, things will still fail, but in this world, we want to start leveraging anomaly detection and analysis. We want to see things coming before they happen and the moment they occur so that we can respond as fast as possible. And in order to do that, we really need our software to respond, to self-heal, to be able to withstand whatever issue until a person can get there and address it. And so we have to test those mechanisms. We have to make sure that those mechanisms self-heal and self-correct well, so that they will save us when things go wrong and not result in an additional problem. And one other thing I've seen in this world is people get complacent. Failure becomes less of an issue and people stop thinking about it. And it doesn't mean that we have to think about failure every moment of every day, but we don't want our skills to atrophy. And so it's important for us to practice, to have these opportunities for game days or fire drills so that our teams remain on their toes. Just as a fire may not break out in one of our offices every day, we still run fire drills on a regular basis because we know that when it occurs, it'll be paramount to respond in a safe and calm manner. And this is the world where we might be looking at multiple service providers, multiple cloud providers, multiple vendors, so that if any one part of our system fails, we have redundancy, a logical redundancy to replace that. So in this world, we really are pushing our system to the limits. We're testing for peak traffic spikes. We're doing broad impacting failures like testing what happens when DNS doesn't resolve. We're testing region evacuation and ensuring that our systems are able to stay active while losing an entire data center or an entire region or an entire cloud provider. But again, we can be doing this in monthly or bi-monthly exercises and at the team level weekly in a way that is safe, unobtrusive, and really saves time in the long run. These outages, back to the analogy at the beginning of the glacier, of the iceberg, take up a lot of engineering time and effort, not just during the outage itself, but in the hours and days of understanding, building the timeline, fixing the issues, meeting and discussing with teams, and rolling out the fix to production. We can save all that time by investing just a bit of good hygiene on a regular basis up front. And that'll help us get to the world that we want to live in, the world where software is treated like a utility. When you turn on the faucet, the water works. When you flip the light switch, the light turns on. And when you go to our website, it always works. It always does what you want it to, because We take pride, right? We write high quality software and we build resilient systems. This is the future. This is what we're aiming for. In 5 or 10 years, all of this will seem like common sense, not that surprising. And that's our goal here, is to help people understand that this is just good engineering discipline that allows you to be more effective and efficient in your day and build more reliable systems that your customers will love. Hope you enjoyed my talk. Hope you found it educational. Hopefully you learned something and you can apply it in your day-to-day life. We're excited to be partnering with OSC Korea. We have a shared vision of helping to build a more reliable internet and to help teams and companies across the globe build more reliable systems. Next up, we have the opportunity to hear from Daniel Kim, a DevOps engineer at OSC. He's going to talk a little bit more about Gremlin.
네, 안녕하세요. 저는 OSC 코리아에서 데브옵스 엔지니어로 근무하고 있는 김대성이라고 합니다. 일단 저희 그렘린 데모를 보여드리기 앞서서 이제 OSC 코리아를 간단히 소개해드리면, 그렘린의 한국 파트너이고 고객의 디지털 트랜스포메이션을 돕고 있습니다. 저희는 마이크로 서비스 아키텍처 전문 기업으로 이제 클라우드 환경에서 오픈소스 기반의 컨설팅과 구축, 운영 서비스를 제공하고 있고, 클라우드 네이티브형 글로벌 솔루션들을 공급하고 있습니다. 대표적인 솔루션이 이제 오늘 설명드리는 그렘린이고, 이제 아이덴티티 영역에서부터 분석 영역에 이르기까지 다양한 솔루션들을 공급하고 있습니다. 네, 그의 글로벌 최대 비영리 단체인 리눅스 재단 한국 지사를 담당하고 있고, 국내 오픈소스 발전을 위해서 후원을 하고 있습니다. 네, 그렘린을 사용하고 있는 대표적인 국내 기업은 이제 카카오페이 외 몇몇 대기업이 도입해서 미리 사용을 하고 있고, 이제 점점 도입 사례가 점점 늘어날 것으로 기대하고 있습니다. 이제 카오스 엔지니어링은 이제 시스템의 취약한 부분을 밝히기 위한 방법인데, 먼저 이제 시스템이 정상 상태인지를 확인하고, 어떠한 장애가 생겼을 때 이렇게 될 것이다 라는 가설을 세운 뒤 이제 그 가설에 맞춰서 실험을 하고, 그 결과가 나오면 시스템을 보완하는 그런 방법론입니다. 지금부터 이제 사스 형태의 카오스 엔지니어링 툴인 그렘린을 소개하려고 하는데, 이제 그렘린은 GUI 기반으로 되어 있기 때문에 편하게 사용하실 수 있고, 이제 지금 보시는 화면은 그렘린에서 어택을 실행할 수 있는 메뉴이고, 이제 서비스, 호스트, 컨테이너, 쿠버네티스 같은 인프라스트럭처 환경, 그리고 어플리케이션에서 어택을 할 수가 있습니다. 어택을 설정할 때는 이제 먼저 어택의 대상을 먼저 선택하고, 어택의 범위, 어택의 종류, 어택의 스케줄을 설정해 주시면 되는데요. 어택의 타입은 이제 리소스, 상태, 그 네트워크 이렇게 크게 나눌 수 있고, 리소스에는 이제 CPU, 디스크의 사용량 및 I/O, 그 메모리에 대해서 이제 부하를 줄 수 있고, 스테이트에서는 프로세스를 죽인다던가 리부팅, 셧다운 기능을 사용할 수 있습니다. 그리고 네트워크에서는 이제 블랙홀, 레이턴시, 패킷로스, DNS 블락과 같은 기능을 사용할 수 있습니다. 네, 이제부터 데모를 보여드릴 텐데, 데모 환경은 이제 지금 보시는 그림과 같이 마이크로 서비스 아키텍처로 구성된 홈페이지입니다. 여기서 제가 보여드릴 데모는 이제 그렘린을 통해서 프론트엔드에 이제 CPU 부하를 줬을 때 오토 스케일이 잘 동작하는지와 서비스가 이상이 없는지, 그리고 광고 서비스에 네트워크 트래픽을 드롭시키는 블랙홀 장애를 냈을 때 그 외의 서비스들은 잘 동작하는지에 대해서 한번 확인해 보도록 하겠습니다. 네, 지금 보시는 화면은 그렘린에 접속하게 되면은 이제 제일 처음 볼 수 있는 화면인데, 여기서는 이제 주로 연결되어 있는 클라이언트들이나 서비스들, 그리고 장애를 일으켰던 종류들에 대해서 이제 다 보실 수 있고요. 제가 아까 첫 번째 가설을 한번 실행해 보겠습니다. 이 프론트엔드 페이지에 대해서 줄 건데, 제가 미리 오토 스케일링을 걸어놨고, 체크를 해놨고, 인프라스트럭처, 디플로이, 프론트엔드. 네, 100을 줄 거고, 네, 이제 지금 보시면 사용량이 엄청나게 증가했고 레플리카의 개수도 늘어나게 될 건데, 네, 3개까지 늘어난 걸 알 수 있습니다. 그리고 홈페이지도 정상적으로 동작하고 있습니다. 이 결과를 보자면 오토 스케일링도 자동적으로 잘 동작하고 있고 프론트엔드 서비스에도 아무런 이상 없이 서비스가 잘 되고 있는 것을 알 수 있었습니다. 두 번째 공격으로는 이제 제가 여기 밑에 보이시는 광고창에 대해서 이제 블랙홀 공격을 한번 해보도록 하겠습니다. 네, 블랙홀 공격이 시작됐고 지금 보시면은 광고창이 안 보이지만 서비스들은 다 정상적으로 동작하고 있고, 네, 아무런 이상이 없는 것을 알 수 있으므로 이제 제가 두 번째에 말했던 가설이 맞게 되는 거죠. 이제 어택을 하나하나씩 냈다면 이제 시나리오로 한 번에 묶어서 할 수도 있거든요. 이제 거기서 이제 제가 이 카트 서비스에 대한 리부팅이 일어났을 때 이 페이지는 5초 후에 올라올 거고, 그 다음에 이 상태를 체크한 다음에 2초 후 이제 다른 공격을 또 실행할 수 있게끔 한번 해보겠습니다. 카트 서비스에 셧다운을 할 거고, 그 다음에 이 페이지에 대해서 200을 받아오면 다른 공격을 하게끔 만들어 놓고 실행 한번 해보도록 하겠습니다. 두 번째 카트 서비스를 체크하는 과정에 이슈가 생겨서 다음 어택을 실행시키지 못했습니다. 이 결과로 제가 이제 카트 서비스를 리부트할 경우 5초 뒤 서비스가 잘 동작할 것이라는 가설이 틀린 걸 알 수 있었고, 그러므로 카트 서비스가 리부트이 일어났을 때 보완점을 더 추가해야 된다는 것을 알 수 있었습니다. 네, 지금까지 그렘린의 간단한 데모를 보여드렸고요. 그렘린에는 다양한 기능을 통해서 광범위하게 시스템을 검증해 볼 수 있는 좋은 솔루션이기 때문에 이제 오늘 세션이 도움이 되셨기를 기대합니다. 네, 경청해 주셔서 감사합니다.